we're going to be looking at square roots. The square root of 9 is equal to 3. The reason why is because 3 times itself, 3 times 3 gives me that specified number of 9. So when I find the square root of 9, I'm looking for what number multiplied by itself could produce 9. Unfortunately, there are some square roots that we don't know. For example, the square root of 20. I don't know a number. 4 times 4 is 16. 5 times 5 is 25. Somewhere in between, and I don't know a whole number. So we're going to have to do some more work. If you can't easily find a perfect square that multiplies that number in the radical, you have to make a factor tree. So 20 would be 4 times 5. 5 is a prime number, can't break it down anymore, but 4 is 2 times 2. Now I have all prime numbers, so the square root of 20 is the same as the square root of 2 times 5. All of those prime numbers at the bottom of my factor tree. Now the interesting thing when I see this, 2 times 2 is a pair of prime perfect squares that would create 4. And I do know the square root of 4 is 2. However, I don't know the square root of the number 5 alone. So the square root of 20 can be simplified to be 2 times the square root of 5. Let's look at another one. The square root of 32. 32 is 4 times 8. 8 is 4 times 2. 4 is 2 times 2, 2 times 2. In this case, I have a lot of prime numbers of 2 at the end of my tree branches. Square root of 32 is 1, 2, 3, 4, 5. 2 times 2 times 2 times 2 times 2. Again, I'm going to look for pairs that I can take a square root for. 2 times 2 is 4, and I know the square root of 4 is 2. Another pair, 2 times 2, and I know the square root of 4 is again 2. Since everything was multiplied together, I'm going to continue my multiplication. However, I have 1, 2 left over at the end that does not have a pair, and I don't know the square root of the number 2 itself, so I will leave that inside the square root. To finish simplifying, outside my radical, 2 times 2 is 4, and I still have the square root of 2. Let's do 2 more. Here you see some multiplication and some division. So let's do the multiplication first. Square root of 18 times square root of 8. I could multiply those together into one large number, but I'm trying to make a factor tree or find a square root of something I don't know. So instead of multiplying them and refactoring, they started as something multiplied together, and I've broken it apart into 18 times 8. Continue to break them apart. 18 is 9 times 2. 9 is 3 times 3. 8 is 4 times 2. 2 times 2. So if I write everything that I have, 3 times 3, 2 times 2 times 2 times 2, all of the prime numbers at the end of my factor tree. Look for pairs. 3 times 3 would create a 9, and I do know the square root of 9 is 3. Another pair, 2 times 2. I do know that 4, the square root of 4 is 2. And I actually have one more pair. 2 times 2 makes 4, and I know the square root of 4 is another 2. There is nothing left over inside my square root, so I do not need the radical. My final answer is 3 times 2 times 2. Or 3 times 2 is 6, times 2 more, my final answer is 12. The square root of 18 times the square root of 8 is the whole number 12. Last problem, a fraction. I can find the square root of each number individually. What is the square root of 45, and what is the square root of 16? I don't know the square root of 45, so I'll make a factor tree. 45 is 5 times 9, and 9 is 3 times 3. So I'd end up with the square root of 3 times 3 times 5. I see a pair that I know. That created 9, and the square root of 9 is 3, and I'm left over with a square root of 5 that I don't know. But that was just for the 45. The rest of it, there was a fraction. The square root of 16. I could make a factor tree, 4 times 4, but I also know the square root of 16 is 4th by definition. So to finish it up, the square root of 45 was 3 square root of 5, divided by square root of 16, which was 4. Final answer. If it started as a fraction, my answer must remain as a fraction. Remember, we're using a factor tree to simplify the square root to a smaller radical with a whole number that we already were able to find a square root for.